Morning guys, so we're going to go through transforming functions. Sorry, try that again. This is where you're just moving a graph in different directions. You might be stretching the graph, you might be reflecting the graph. Okay, so general rules, which you'll have seen most of these before at GCSE, is that if your original function is just the graph y equals f of x, then f of x plus a, so something outside of the whole function, actually moves your graph up by a values, because this is affecting the whole y value essentially. So that can also be described as a translation, 0 in the x direction, positive a in the y direction. So if it's a minus a outside, it's the opposite, you're going to move down by a. So again, could be described as a translation, 0 in the x direction, but negative a in the y direction. Now these are the two to be careful of. When you've got what's being affected is inside the bracket, so it affects the x, it's the opposite of what you expect. So it's still going to move it in the x direction, but a positive a actually moves the graph left by a. So your translation would be minus a, 0. If it's x minus a, it moves it to the right by a, which means the translation is positive a, 0. So just be careful that when it affects the x terms, it's the opposite of what you expect. When it's the y terms, it's exactly what you expect. So if I look at this one, a f of x, this is multiplying the whole function by a. So you're going to stretch your whole function in the y direction. Okay, so in other words, you're just going to multiply your y values by a. If you affect the x, opposite of what you expect, so it's affecting the x, so it is going to stretch it in the x direction instead of the y. But this time the scale factor would be 1 over a. So if you'd got 2x, you'd actually half all the x values. If it was 3x, you'd do a third of each of the x values. And then the last two you need are your reflection ones. So if you make the whole function negative, all your positive y values now become negative, all your negative y values now become positive. So it's a reflection in the x-axis, or the line y equals 0. Okay, and then with the x one, if you're making all your x terms negative before you put them into the function, it basically means instead of your graph going that direction, it's now going to reflect and go that direction. So it basically means it's going to reflect it in the x-axis, or sorry, in the y-axis, or the line x equals 0. So you can get questions at A level in two different ways. They're either going to give you a graph and then ask you to draw the graph of f of x minus a, or they could show you the moved graph and ask you to give it as a description, which is where you describe it as a translation of 0, whatever. So we're going to go through how to draw the graphs in a minute. So first things first, can we please use a ruler? Okay, axes drawn with a ruler, please. You've got the following diagram is given as this. I did miss O there for the origin, obviously. We want to sketch each of these following graphs, and we want to show the points O, A and B where they ended up in terms of your graph. So for the first one, and like I said, we're going to use a ruler, sorry, just a bit right there, to draw our set of axes. Now for A, it's f of x plus 1. So this is affecting the x values. So it's going to do the opposite of what you expect. It's going to move it 1 left. So if you look at your points, this x coordinate is going to go from 1 to 0. This x coordinate is going to go from 3 to 2. And this x coordinate is going to go from 0 to minus 1. So it's going to be the exact same curve. But this point here is now going to be A at 0, 4. Sorry, that was a 4. For point B, it's now going to be 2, 1. Notice each time it hasn't affected the y value. It's just subtracted 1 from each of the x values. And this point here is now minus 1, 0. Okay, so you've got each of your new points. Sorry about that, was just off the screen. So if we now look at B, that was f of x plus 1. We're now going to draw the graph of f of x minus 1. So minus 1 is going to move it right by 1. So redrawing your axes. Okay, so f of x minus 1 means opposite of what you expect. It's an x direction, so it's going to move it right by 1. So if you think about your 0, 0 is now going to move across to 1. We know A, instead of being 1, 4, is now going to become 2, 4, and B is now going to become 4, 1, because each of the x values have just added 1. So you're going to get a curve that looks like this, with A now being 2, 4, B now being 4, 1, and the O point now being 1, 0. So you can see from the original graph, all we've done is add 1 to each of our x values. If I look at the third one, I'm drawing the graph of y equals f of x minus 4. So remember, the minus being outside of your function means that what you're actually going to be doing is moving, let me just rewrite the question. So the minus 4, because it's on the outside of your function, it means it's going to move the whole function down by 4. So that means this point that's at 0, 0 is now going to be at minus 4. This point here, which is at 4, is now going to end up at 0. This point, which is currently at currently at 1, is going to end up at minus 3. Okay, so you've got, obviously, you're going through at minus 4. We know it's going to touch the y-axis, so for A at 1, 0. And then the B value is going to be 3, minus 3, so it's going to be down here somewhere. Okay, and then you're just going to sketch in what your graph looks like. So it touches at A, goes through point B, and then goes back up. So you can see all we've done is move the whole graph down by 4. So each of the y values got smaller by 4. 4 became 0, 1 became minus 3, 0 became minus 4. So I should probably write that as a coordinate. Okay, so you've got all of your new points. If we look at part D,